the probability of a student walking to school is 0.2, the probability of her cycling skill is 0.5, and the probability of her getting a lifted skill is 0.3. If she walks, the probability of her being late from school is 0.4. If she cycles, the probability of her being late is 0.25. And if she gets a lift, the probability of her being late is 0.35. So let's do this, alright? So we have a tree diagram. 0.2 for walking, 0.5 for cycling, and 0.3 for the lift. Okay? Now there's two options after that. You're either going to be late or not late. So if your probability of being late is 0.4 when you walk, that means your probability of not being late is 0.6, because they both have to add up to 100% or 1. Okay, so that's where we get the 0.6 from. So the information we're given is when they're late. Okay, so example is we're given 0.4, we're given the 0.4, we're given the 0.25, and we're given the 0.35. Therefore we calculate that not being late is 1, take away the green number, take away the yellow number, right? And this is the tree diagram we create. Alright, next one. Find the probability that if the student cycled to school on a particular day, given that she was late. Now this means we need to find out the probability of being late. So we're going to find out the following probabilities. Okay, so if you imagine the following routes, we need the total value of being late. Okay, so get this. So we walk and we're late. That's one possible route for being late. We cycle and we're late. That's the other possible route for being late. And finally, we get a lift and we're late. So essentially what you're doing here is you're adding up the total probability that you're late, which is 0.2 multiplied by 0.4 plus your 0.5 multiplied by your 0.25, and finally plus your 0.3 multiplied by your 0.35. Okay, and when you add up the three of them together, you get these probabilities here, and you get an answer of 0.31. So that's the probability of you being late. Probability of being late is 0.31. However, find the probability that the student cycled to school on a particular day given she was late. So you want the probability that she was late given she cycled. Okay, now there's a formula for that, okay, and we might remember from our tables or it's called conditional probability. What's the probability of A happening given that B has already occurred? So it's actually the opposite way around, just as well I read that. Find the probability she cycled given that she was late. PC/L. Alright, and what you want is the intersection. You want the probability of she cycles and she's late over the probability that she is actually late. So the probability she's actually late is 0.31, and the probability that she cycles and is late, cycle and being late, is your 0.5 times your 0.25, which is an 8. So it's 1 over 8. Okay, so it's 1/8 over 0.31, and if you put that into the calculator, you get 25 over 62, or you could have 0.0432, something like that. Okay, so next question. Box B contains 2, 3 and 5 pens, 2 greens, 3 reds and 5 blues. That means 10 pens in total. 3 pens are selected at random from the box without replacement. What's the probability that the 3 pens selected are different colours? Okay, so the 3 pens selected are different colours. So what way can we make this happen? Okay, so the way we can make this happen is by doing it So order is important. Okay. So she selects a random row placement when probably 3 pens are selected from different colours. Alright. So what you could say is it's the probability of green, blue, followed by green, red and blue. Then you could also pick red, green and blue, or you could pick red, green, blue. Oh, I should have done it that way. Sorry, my fault. Green, red, blue. Green, blue, red. You could go for red, green, blue. Red, blue, green. You could also go for blue, green, red, or blue, red, green. There's basically 6 ways that can happen. Now, if you're doing it the factorial way, you can do 3 of them. You can put any 3 colours in the first box. Then once you pick a colour, there's 2 colours left for the second box and 1 colour left for the third box, which is 6 different choices, or 3 factorial choices, which is also 6. Now, what's the probability of each one of these happening? I think they're actually all going to be the same. It's all going to work out as the same number anyway. So I'll give you an example. Probability of choosing a green is 2 in 10. The probability the probability of choosing a red is 3 in 10. Oh, sorry, 3 in 9, because you're not replacing it after you take the first one. And then probability of getting a blue will be 4 in 8. Now, if you look at any other combination, they all turn out the same. So let's do blue, green, red as an example, alright? And we're going to add all these combinations together. So if we were doing blue, green, red, it'd be blue would be 5 out of 10, green would be 2 out of 9, and finally red would be 3 out of 8. You can see that the top 3 numbers, sorry, what was that? Blue was 5. Just I got to check that. The top 3 numbers are always 2, 3 and 5, and the bottom 3 numbers are always 10, 9 and 8. So essentially you can just do the probability of one of them, and you do this 6 times, but instead you can just multiply by 3 factorial. Okay, and that should give you the answer you're looking for. And when you put that into the calculator, you'll get 1/4. Okay. Now, another way of doing this question is using combinations, alright? So if you imagine this, you have 10 pens and you choose 3. That's the total number of combinations possible. 10, choose 3, which is 120 different combinations, alright? Then you do all the ways you can choose each colour. Well, I can choose green as 2C1. I can choose red as 3C1. And then finally, I can choose blue as 5C1. And I would throw all that into the calculator. It also looks like this for those of you that aren't familiar. And you'll get the same answer as 1/4. Okay, so 2 different ways of doing the same question. Okay, now we're on to B part 2. Pens are then replaced in the box, and the same process is carried out a total of 8 times. Find correct the 4 decimal places the probability that the 3 pens selected will be different colours at least twice. Okay, so at least twice. So okay, now at least twice would mean probability getting 2 plus probability getting 3 plus probability getting 4 and then all the way up to probability of getting 8. Now that's a lot of workings, alright? Now it's actually the same thing as 1, which is 100%, take away the probability of getting 0 and the probability of getting 1. This method only has 2 calculations versus, what is it, 6 calculations, so I'd recommend that you do it this way. So the probability of getting 2 successes, 3 successes, all the way up to 8 successes is the same thing as 100% or 1, take away the probability of no success, take away the probability of 1 success. Now, we're going to do this using the binomial expansion, so NCR, P to the power of R, Q to the power of N minus R. So it's a Bernoulli trial, which means the probability of success and failure remains the same. Okay. Now, your probability of success we determined to be 0.25. This means your probability of failure is 0.75. Now, if we're going for 0 failures, or sorry, 0 successes, it's going to be 8C0, 8, no successes. Then your probability of success, you have none of them. So you have no successes. And you have 8 failures. Okay? Now, your probability of 1 success is 8 attempts, 1 success. Probability of 1 success is 0.25 to the power of 1. And if you had 1 success, it means you had 7 failures. 0.75 to the power of 7. Now to calculate the probability of this all in one go, we just take away our two calculations, like so. And 1 take away both those numbers, put it all into the calculator, and your answer should come out to be 0.63, I believe. 0.632a. Say 0.6329. Okay, well done. Now, finally, something a bit handier. Find the shortest distance between 2 parallel lines, 3x minus 4y minus 16 and 3x minus 4y plus 14. Okay, so you imagine 2 lines and they're parallel to each other. What I could do is, if we could just find even 1 point on one of the lines, then I could use the perpendicular distance formula. D equals ax1 plus by1 plus c all over the square root of a squared plus b squared. That's what I'd be inclined to do. Find 1 point on either line and then do the D formula. So there's a formula for the distance of a point to any line you want. So I'm going to choose the top line, seems quite easy, and I'm going to put x equals 0, and that way I can find out a good y value. So 3 times 0 minus 4y minus 16 equals 0, and then we're going to get move the 4y over. Minus 16 equals 4y, y equals minus 4. This means that this point is 0 minus 4. And I'm going to find the distance of this point to this line here. And the a value will be 3, the b value is minus 4, and the c value is 14. Okay? Now, I'm going to throw the answer, I'm going to throw the numbers into the formula. The x1 and y1 value are the point you're measuring the distance to the line with. Okay, so it's going to be 3 times 0. What's it? Minus 4 times minus 4. And then plus 16, or say plus 14. All divided by the square root of 3 squared plus minus 4 squared. Okay, now you're going to put all that into the calculator. And what you should get on top is you should get 30. Now it has to be a positive answer. That's what the 2 vertical lines are about. Has to be a positive answer. 30 over 5, the d value is 6. Okay, so that's handy enough. Now, find the equation of the line which is parallel to lines L1 and L2 in equidistance from both lines. Oof. Equidistance from both lines. So we have two lines like this. Okay, and what we want to find out is, so we have two lines, and then what it wants is the line that is in the middle and is equidistant from both lines. Okay, so that's going to be interesting. Now, what we can be assured is it has the same XY combination. See, in any parallel line, the XY combinations are the same. So it's 3x minus 4y. And then some unknown value k. And that will equal 0. Okay. Now, I suppose the way I could do this is, if the two original lines are a distance of 6 apart, that means that the new line would be a distance 3 apart. And we know a point on this line. We know the point 0 minus 4. So I could once again, and we know that the equation of the line is like this. So I could once again go for my this formula here. Bring the whole thing down. I could do this as well, like so. And I could try it out this way. So what I'm thinking is the D value is 3, the A value is 3, it's still x1 and y1, so 3 times 0 minus 4 times minus 4 plus c, or plus k, because it's now k, and then it's all over the square root of 3 squared plus minus 4 squared again. Okay, and what we're going to get here is we're going to get 3. Now, does it say line or lines of a line? So it should be just the one answer. So what we're going to get here is, that's k plus 16. And this is 5. And then we're going to get k plus 16 equals 15. Now, there's two answers that could do that. You either have an answer of minus 15 or plus 15. And that would imply that either k equals minus 1 or k equals, what is it? K will equal 17. Sorry, k equals minus 1 or has to equal plus 15 or minus 15. So k plus 16 equals 15. That's k equals minus 1. Or k plus 16 equals minus 15. K equals minus 31. Now, here's the problem with this question, alright? The problem is you have to find the line, you have to find the k value that's in between the two lines. Okay? Now, if you were to square this out, square both sides out, and get 225 equals k squared plus 32k plus, what's it, 16 squared? 256, and solve that quadratic equation, you'd still get these two answers here. I just thought it was faster to do it this way. Alright, now there's two answers, minus 1 and 31. Minus 1 and, what was the other one? Minus 31. Now, it has to be in between these two lines. Okay, so just going to explain a bit of background to this. as well. It's annoying when you have to explain backgrounds. Alright, so if you imagine, I'm going to show you. We're just going to park these two answers off into the corner for a minute, okay? And imagine this. We all know the value y equals mx plus c. It's when you have y on its own, you can find out what the slope is. So in both cases, you can have 4y equals minus 3x plus 16 and 4y equals minus 3x, minus 14. Okay? And in both cases here, we can divide by 4. And we get y equals minus 3 over 4x plus 4. And we get y equals minus 3 over 4x. Now what's 14 minus 14 divided by 4? 3.5 or 3.5, right? Now, if you see that 3.5 and 4, you can see that they're both sort of with the minus 3.5 and 4. So if you imagine the xy axis like this, so I'm just after drawing the xy axis, and that's 0, 0. Okay, the first one has a slope of minus 3/4 and crosses through 0, 4. So just roughly something like this, alright? Then if I clone this line, Control D, and bring it down, the other one crosses at minus 3.5, which is here. Okay, and our other line is in between, dead center. Oh, sorry, Control D again. Control D. Oh, I have to do this again. Control D. Now, so we have to figure out which one of our two answers is actually in between the two numbers. Well, for me, it's remember I'm definitely doing A part 2 at the moment, alright? And I was just discussing my two answers, alright? So I actually have a separate method for doing this as well. Now once again, if I said 4y equals minus 3x, and what did I say my two answers were again? Minus 1 and 31. So that'd be a minus 1 and that'd be a minus 31. So one of them would be 3x plus 1, and then divide by 4, minus 3/4 x plus a quarter. 0 1/4 is exactly in between the two lines. So that's how I know that my answer of minus 1 was the correct answer. So the line in question is definitely 3x plus 4y. And then what do we say it was? So 3x minus 4y. 3x minus 4y, and the k value is minus 1. That's definitely the correct answer. Now, an alternative method for doing this question is the following. You know that the answer is 3/4. So you know that the slope is minus 3/4. You've already established that. The slope is minus 3/4. What you could do is you could half the points 0, what was it? 0, 4. Sorry, I'll just do this from scratch. I'm getting a bit tired at this stage. 4y equals minus 3x. Sorry, 3x plus 16. Definitely getting tired. 4y equals 3x. Bring the 4y over here, so 3x minus 16. Sorry, lads. And then, sorry, that's 3/4 x minus 4. Oh god, I made a total hames of that. Alright lads, I'm just thinking I'm going to scratch that and call it question 1.